Okay, so now we move to the next part of our lesson, expected value of a discrete random variable. Okay, so if you take a set of observations from a discrete random variable, you can find the mean of those observations. Okay, so what are we doing now? We are trying to find the mean of the observations from a discrete random variable. As the number of observations increases, this value will get closer and closer to the expected value of the discrete random variable. Can you see? So let's read this again. The expected value is a theoretical quantity and gives information about the probability distribution of a random variable. Okay, the expected value is sometimes referred to as the mean and is denoted by mu. Can you see? The expected value, in other words, is actually the mean value, like the average value in the data set. Okay, so the expected value of the discrete random variable x is denoted. So officially we give the notation ex. Can you see? Inside capital E and inside you write capital X, the random variable ex, and defined as ex equals summation x times, what have we done? We have taken the summation of the product of x into the probability. Okay, so what is the expected value? The summation of x times the probability of that particular x. Okay, so that's the first thing. This is the main equation you need to know. Okay, calculating the expected value or calculating the mean. So it's found by taking the sum of the products of the x with its respective probability. Okay, and then there's an extra part here. If x is a discrete random variable, then x square is also a discrete random variable. You can use this rule to determine the expected value of x square. Okay, so they're also teaching you how to get the expected value of x square. So expected value of x square is equal to summation x square times the probability of x. I think the best thing to do here is let's go for some examples to see how to use these equations. Okay, so for example, let's just quickly look at this example to understand what they're talking here. So a fair six-sided dice is rolled. The number that appears on the uppermost face is modeled by the random variable capital X. So when you're working with the dice, what are the expected outcomes? What are the outcomes you expect? 1, 2, 3, 4, 5, 6. So simple X. Simple X, you have 6 values. 1, 2, 3, 4, 5, 6. And when it comes to a dice, we work with fair dice, right? Which means the probability of each outcome is 1 over 6. Do you agree? The probability of each outcome is 1 over 6. Okay, so how do you get the expected value? The rule is you multiply the x value with its respective probability. And you and you take the sum. Okay, so the first one, can you see what's going on here? So what we do is we take the x and multiply with the probability. So in this case, I'll do it over here. The expected value is 1. So the x value is 1. You multiply by the probability, 1 over 6. Are you with me? 1 into 1 over 6. That's the first pair. Plus the next pair. The x value is 2. The probability is 1 over 6. So plus 2 into 1 over 6. Can you see? Plus the next value. Multiply x and the probability. 3 into 1 over 6. Can you see? Plus 4 into 1 over 6. Plus 5 into 1 over 6. Plus 6 into 1 over 6. Can you see? So this is how we get the expected value. And you can see they have calculated it and the answer becomes what? It becomes equal to 3.5. The answer becomes equal to 3.5. Okay, so 3.5 is the expected value or the average, the mean value. So they say here, if you know the probability distribution of x, then you can calculate the expected value. Notice that in example 7, the expected value is 3.5. Do you see? The expected value is 3.5. But do you really have, now it's a discrete distribution, right? Do you have an x value called 3.5? No, but if you try to get the probability of x equals 3.5, that is 0. Okay, because there is no value called 3.5. Then the expected value of a random variable does not have to be a value that the random variable can actually take. Do you see? So this mean that you are getting, it could now, the only x values you get here 1, 2, 3, 4, 5, 6. But the expected value you are getting here is a value that the random variable doesn't actually take. Instead, so what does this say? Then what is the use of it? So instead it tells us that in the long run, we would expect the average of all rolls to get closer to 3.5. So if you do this, if you if you toss these dice, or if you take in a large number of tosses with these dice, the average value would come closer to 3.5. So that is in the long run. Can you see? In the long run means when you repeat this experiment many times, the average of all the rows. Can you see? So if you take all the possible rows, I mean, if there's infinite amount we can do, right? So they say if you take everything, then it will get closer to 3.5. That's what we mean by the mean, the expected value. Okay, in the long run, what would be the average? What would be the mean that you can possibly get in the long run? Is this clear? Okay. Okay, so we'll move to exercise 6C. I'll start with question number 2. The score on a biased dice is modeled by a random variable x with probability distribution. So it's given to you. You can see that in this case, can you see different x values are having different probabilities? Can you see? So over here, like the x value 1 has a probability 0.1, x value 2 has probability 0.1, and 3 has probability 0.1, but x value 4 has probability 0.2. Can you see? So in this case, the probabilities, the way the certain numbers occur, there is a difference. I think you can see over here, the which number occurs the most. If you take this particular table, which number has the highest chance of occurring? So you can see it's x equal 5 because x equal 5 has the highest probability, isn't it? So x equal 5 has the highest probability. Okay, so let's go for the mean. So Ex equals summation x into probability of x. So summation x is 1 into probability 0.1 plus 2 into probability 0.1 plus 3 into 0.1 plus 4 into 0.2 plus 5 into 0.4 plus 6 into 0.1. Can you see I multiplied the x with its respective probability? How much is the answer? 4. So expected value, the expected value is going to be 4. Okay, and then let's get the Ex square. How do you get the Ex square? Summation of x square into probability of x. That was the rule, right? You take the x square value and you multiply with the respective probability. X square value, so what is the first x value is 1, right? So squaring means it's 1 square. Can you see? You square 1 into probability of 1 is 0.1. Okay, we only square the x value. We will not do squaring to the probability. Okay, only the x value is squared. Okay, plus go for the next person. The x value is 2. 2 square into probability is 0.1. Plus the next x value 3. 3 square into probability 0.1. Plus 4 square into probability 0.2. Plus 5 square into probability is 0.4. Plus 6 square into probability is 0.1. Are you with me? Okay, so how much is the answer? It's a matter of typing everything in the cal. 18.2. So that is the Ex square value. Okay, so I'll move to question number 5 next. The random variable x has the following probability distribution. So x values are 1, 2, 3, 4, 5, and the probabilities, I think you can see it's 0.1. And for 2, there's a probability A. For 3, there's a probability B. And for 4, there's a probability 0.2. And for 5, there's a probability 0.1. Given that Ex is equal to 2.9, find the value of A and the value of B. So how do you do this? So first we'll make the equation for Ex. Ex equals 1 into 0.1 plus 2 into A plus 3 into B plus 4 into 0.2 plus 5 into 0.1. Are you with me? So the expected value is 2.9. We can make one equation here with respect to A and B. 1 into 0.1 is 0.1, 2 into A is 2A, 3 into B is 3B, 4 into 0.2 is 0.8, 5 into 0.1 is 0.5. So 2.9 equals, how much is the total addition? 0.1 plus 0.8 plus 0.5 is 1.4 is equal to 2a plus 3b. So 2.9 minus 1.4, right? So 2.9 minus 1.4 equals to 2a plus 3b. 2.9 minus 1.4 is 1.5 equals 2a plus 3b. So this is the first equation. This is the first equation. Okay, then let's go to the next one. 0.1 plus a plus b plus 0.2 plus 0.1. What am I doing now actually? Because you can see I made one equation with respect to a and b, but it's not enough, right? Because there are two unknowns, we need another equation. So what am I doing here? 0.1, can you see I'm adding all these probabilities? 0.1, a, b, 0.2, 0.1. So what was the rule we learned in the previous part? The rule is always the total probability in a probability distribution must be equal to 1. The total probability must be equal to 1. So I get here a plus b plus 0.2, 0.3, 0.4 equals to 1. So a plus b equal 1 minus 0.4 is 0.6. This is the second equation. Okay, so we have a pair of simultaneous equations now. So all we got to do is solve. So maybe I'll make a the subject from the second equation, 0.6 minus b. I made a the subject. And then I'll substitute equation 1. So I get here 1.5 equals 2a plus 3b. 2a inside brackets, a is 0.6 minus b. 2a plus 3b. 1.5 equals 2 into 0.6 is 1.2. 2 into b is 2b plus 3b. 1.5 equals 1.2 minus 2b plus 3b is plus 1b, right? 1.5 minus 1.2 equals to 1b, which is how much? B is equal to 0.3. Are you with me? B is equal to 0.3, and let's substitute that value, the B value. So A plus B equals to 0.6. So A is what we are trying to find. B is 0.3 equals 0.6. So A equals 0.6 minus 0.3, which gives me what? A is 0.3. That's the answer. Okay. Question number 6, the discrete random variable x has a probability function a into 1 minus x. So you can see these are for the x values -2, -1 and 0, and b for x value 5. Given that ex is 1.2, find the value of a and b. The first thing to do here is to actually build the probability distribution table. So we'll go for this. X values are -2, -1, 0, and 5, right? And then let's go for the probability values, probability x. And let's fill this table. Okay. So when x is equal to -2, what's the probability? So it's a times 1 minus x, right? A times 1 minus x is -2, which means how much? 1 minus minus is 1 plus 2, which is 3. So 3a. Do you agree? When x is -1, it's a times 1 minus -1, which is 2. So 2a. When it's 0, 1 minus 0 into a. So 1 minus 0 into a is a. And when x is 5, the answer is directly b. There is no relationship with x here. So which means you should just write b. Okay, so EX value is given to you. So we'll make one equation with that. Expected value equals X into probability minus 23A plus minus 1 into 2A plus 0 into A plus 5 into B. Let's input the value. EX is 1.2 equals minus 6A minus 2A. 0 into A is 0 plus 5B. So 1.2 equals minus 6A minus 2A is minus 8A plus 5B. Equation number 1. Are you with me? The second equation is made by what? The second equation is made by the fact that the total probability is equal to 1. So always the total probability is equal to 1. 3A plus 2A plus A plus B should be equal to 1. So 3, 4, 5, 6, 6A plus B is equal to 1. This is our second equation. And now we have to solve the two equations simultaneously. So from the second equation, I can easily get B is equal to 1 minus 6A. And let's substitute that to equation number 1. So 1.2 equals minus 8A plus 5 times the B value inside brackets is 1 minus 6A. Are you with me? So then we get here 1.2 equals minus 8A, expanding the bracket, 5 into 1 is 5, minus 5 into 6 is 38. 1.2, so we get here 1.2 equals minus 8A minus 38 is minus 38A plus 5. Is that okay? And then we get here, I get here plus 38A equals 5 minus 1.2. How much is it? 5 minus 1.2 is 3.8. So A equals 3.8 divided by 38. How much is it? 0.1. 0.1. Okay, and then substitute the A value. So B equals 1 minus 6A. So I substitute the second equation where B is subjected 1 minus 6 into 0.1. So 1 minus 0.6, right? Which is B equals to 0.4. So these are the A and B values.